Welcome to the webinar. I'm Eleanor Reid. I am next year's chair of the Professional Practice Committee, and I'm delighted to welcome you all to our 7th webinar of the year. Today's event is supported by ACAD and Arcadis. And before I welcome our panelists, I would just like to introduce the British Society of Soil Science as hosts of today's webinar. So we are an established international membership organisation and charity committed to the study of soil in its widest aspects. We bring together those working within academia and have a growing membership amongst practitioners implementing soil science in industry and those with a keen interest in soils. We have one more Zoom into soil this year, making a total of 8. And this is supported by Cranfield University and will take place on World Soils Day, which is Monday, the 5th of December. So before we begin, just some basic housekeeping. As there's so many of you here today, all of your microphones have been muted. We will be taking questions at the end of both presentations. So please could you submit any questions that you have by 12:50. Just to allow us to get through as many as we can. Although there is a raise your hands button, we won't be using that unless the presenter specifically asks for a show of hands. So today's presentation has been awarded BASIS and NRO SO CPD points. If you are registered with either of these bodies, please contact us directly after the event. Finally, please be aware that we are recording today's presentation. So I'd now like to introduce our first presenter, which is Simon Hay. Simon has 15 years of experience in land contamination risk assessment, working at Arcadis in Cambridge. His focus is in quantitative risk assessment, covering both environmental and human health assessment. Project work has spanned a diverse range of public and private sector work, including many sites under the Part 2A assessment regime. Simon was a member of the SOBRA asbestos working subgroup with further areas of expertise including statistical assessment and assessment of asbestos risks from brownfield sites. So over to you, Simon.
Okay, hello everyone. Thank you for inviting me today to talk at the Society of Soil webinar. I hope you find this talk interesting on land contamination risk assessment. It's intended as a high-level introduction to some of the concepts of land contamination, and I hope you find some synergies with the field of soil science. So thanks for the introduction, Eleanor. My name is Simon Hay, and I am a specialist in land contamination risk assessment, also with a specialism in asbestos risk. So just a quick overview of what we're going to be talking about. So first of all, I will give a introduction to the land contamination risk assessment framework. Next, I will talk about one of the fundamental concepts of land contamination risk assessment, which is a conceptual site model, and then we will look at some contaminants in more detail. Okay, so first I'll talk about the land contamination risk assessment framework. So our industry is underpinned by a guidance document called Land Contamination Risk Management. This provides a framework under which we work. It doesn't set out the specifics, however, on how work is done. There are 3 key stages to the assessment process, which ensure that the actions taken are proportionate to the scale of the problem and the sensitivity of the site. Start with risk assessment, move on to options appraisal, where we consider what action may be necessary, and the final stage is remediation and validation. That's where we are proving that the pollutant linkages of concern have been successfully dealt with. And each stage of this is underpinned by the conceptual site model, which we'll look at in a bit more detail later. So just very quick mention that, as I said before, our guidance framework is risk-based, and this ensures that we focus on the sites with real contamination issues, that we target the pollutant linkages of concern, and that then it helps us with sustainable decision making. I wanted to look now in a bit more detail on the risk assessment element of the process. So this determines the need for action, but also the pollutant linkages of concern for what action needs to be taken. It's an iterative process where we continually refine the conceptual site model. Sites may be screened out at any stage of the assessment process. So the first stage is desk study, where we identify whether or not a contaminative source is present. We then move on to site investigation if the site was of sufficient concern. This may be where we take soil and groundwater data. The data we collect would be initially screened against generic assessment criteria, and that enables us to screen out the low risk sites. For sites then requiring further assessment, we move on to the a more detailed assessment stage, and sites coming out of that requiring more work, that is where we consider remedial options. With the risk assessment process, we would be targeting the pollutant linkages specifically in those remedial options. But there's always a case for considering the sustainability of any action to be taken, and then potentially to undertake further assessment to fully justify the remedial action. So just moving on to the conceptual site model fundamentals. So the conceptual site model, also referred to as a source pathway receptor approach. So the first part obviously is a source where we need to have a contaminant that's potential to cause harm. Then we have a pathway, which is a mechanism by which the contaminant can reach the receptor, and then a receptor, which is something that can be harmed by the contaminant. For a risk to be realized, all three elements need to be present. So just have some examples of different sources here. Thing I wanted to talk about is a difference between point sources. It tends to be point sources that we identify in desk studies, but we also would have more diffuse sources. So something like pesticides, for example, widespread usage, so it could be considered a contaminant. However, if they're applied properly, they should degrade in the environment. So it would be more the point sources that we consider. So something like mixing points or storage areas. Other examples of point sources we have here: fuel tank, animal waste storage. Buildings can be sources of contamination. So we'll be talking about asbestos in more detail later, and lead paint. We also have diffuse sources that could come from natural background in soils, also from human activities like burning of fossil fuels. As background issues are harder to deal with because often the benefit is less likely to be realised. Okay, and moving on to receptors. So there are three broad categories of receptors that we consider. So first of all, human health. So different end uses, different scenarios determine the type of receptor and the sensitivity. So for example, a residential scenario, we may consider residential a child receptor, whereas a commercial setting may be an adult worker. Water resources. So this is where we consider aquifer resources. So that would be for drinking water or as a base feed for surface water. And also surface water, which would be either an ecological resource or drinking water. And finally, ecological receptors. Now these tend to fall within water resource because it's often the water environment that's being affected. We tend to specifically consider it when it's designated sites. It would be a different scenario if the protected site was within our site. So then we might need to consider the soil quality. So just to call out some of the human health exposure pathways. So these are the mechanisms by which harm can occur to people. So the active pathways depend upon the scenarios or end uses for the site. Some pathways will be more important than others, and this depends on the end use scenario. So broadly speaking, the pathways we consider are dust inhalation and ingestion, vapor inhalation, dermal contact with soils, and consumption of produce. So there's quite a difference between indoor and outdoor exposure, and how the pathways play out. When we consider the pathways, there are lots of things that affect just how active they are. So things like the site setting and human behaviours. But within our models, we have generalised worst case scenarios that we use. So if we need to look at things in more detail, we can more specifically look at these pathways and potentially measure parts of the pathway, things like take up in vegetables, indoor vapor or dust samples. Next, the pathways affecting water resource and ecology. So contaminated soil may leach into the aquifer. When an aquifer is then impacted, it can the contamination within the aquifer can laterally migrate towards surface water. Another pathway to consider would be direct runoff into a surface water feature. So these pathways will also be relevant to ecological receptors. Less commonly, we may have a situation like this shown where we have deposition of waste material onto designated sites. So here we have a landfill that was being eroded onto a protected shoreline. Okay, so now we're moving on to look at some contaminants in more specific detail. So first of all, I thought it was useful to introduce some of the concepts of how contamination is held within soils. So contaminants may be associated with the organic matter within soils. They may be held dissolved within pore water, or they may be present as particulates. So metals and organic compounds are typically bound in quite different ways. So how a contaminant is present in soil really depends on just how it got there. So something like a historical fuel leak may have been held within the soil matrix, whereas fragments from asbestos or from the lead-based paint, there would be more dispersed as fragments throughout the soil. Another thing to think about is just how the contaminant is dispersed across the site. So we may have airborne or a spill, and that would be a point source, and then lower concentrations coming out in a plume. but if we were dealing with an imported soil to the site, then we wouldn't see this effect, and it would be more potentially more evenly distributed across the site. So moving on to some examples. First of all, I wanted to talk about metals and the common example of lead. So lead, many industrial uses and sources of lead. It is known to have effects to human health, including brain damage, and also ecotoxic effects. So in terms of sources, many metals, including lead, can accumulate from activities which things like burning of materials or sewage sludge. I gave the example before of the point sources, so maybe lead-based paints. We may have airborne contamination from burning that could be dispersed over a large area, or more recently from traffic. Lead in particular, we have some areas of the country with particularly high background concentrations that may be above regional screening criteria. And of course, we always have the potential for imported nasties on site in reused soils. So in terms of the pathways for lead and other metals, because it's not volatile, we're just considering the dust and dermal pathways and potentially getting into homegrown produce. So it's worth noting that there'll be no pathway present if the soil was covered. In terms of risk to water resources, there's a potential for leaching. This depends on the mobility of the species. And something like lead, it's often of quite a low mobility, particularly something like the paint fragments example. Next, I wanted to talk about hydrocarbons, and specifically polycyclic aromatic hydrocarbons, as they're very common and ubiquitous, associated with many human activities such as burning. Various sources, so from oils, from combustion projects. We also have background concentrations relating to human activities. So these will typically be higher in urban and industrial settings, but we also have concentrations in agricultural settings from burning activities that occur there. There are many hidden sources from our industrial past. So things like blacksmiths, hop kilns, lime kilns were widespread throughout the country. These could be point sources, but often we have reuse of the ash material associated with the burning, things like paths, fill material, or even added to soil. So pHs can really get spread around, and again, are imported soils to sites. In terms of pathways, it's similar to lead, but for some pHs they also have some volatility, so the vapor pathway may also be active. They generally have very low environmental quality standards. So when we're assessing risk to water, we might want to think about general background quality as well. Right, finally, moving on to asbestos. So asbestos, as you probably know, something that's been heavily used during the 20th century. Final forms of asbestos were not banned until 1999. So it's quite widespread. Its properties of being fireproof and the fact that it doesn't rot has always made it an attractive building material. So asbestos, it's harmful to human health and it causes respiratory diseases. I have some examples here of where asbestos may occur. So particularly building materials and insulation. Release from building materials would often be during demolition or maybe deterioration of those materials during weathering. Now, some asbestos containing materials have a much higher potential to release fibers than others. So some of the examples I have here, we've got asbestos floor tiles in the top right. relatively low percentage of asbestos with it's highly bound, and then below that we have a loose fibre fill, so there's a high fibre release, and somewhere between those we have the cement bound asbestos form that we so commonly see. So again, asbestos, there are often low background levels which are associated with human activities. And it is often associated with imported soils. I would particularly be wary of historically imported soils. There's been a lot of changes in asbestos testing methods over the years, and in the past we wouldn't have picked up things like free fibres within soils. One of my sort of favourite examples of where you find unexpected asbestos contamination is often on golf courses, as they typically need to import a lot of additional material. So as far as exposure pathways go, it is only the inhalation of dust or ingestion of dust pathways that are relevant to asbestos. Here's some examples of where we have where asbestos has been recovered from soils. So many different forms can be found. When an environmental consultant is assessing a site, we would identify suspected asbestos, and it would be confirmed by a specialist or laboratory. This slide is hopefully interesting. Explains some of the challenges for assessing asbestos risk. So all three of these samples have similar concentrations of asbestos within them, but the risks from them are very different. So we have on the left a cement-bound ACM, where the risks are fairly low. In the middle we have a sand with loose fibres in, and then on the right we have a granular material with fragments in. So there's a much higher potential for release if it's less bound. So our screening process for asbestos needs to be much more sophisticated than simply considering an acceptable concentration. I just wanted to give an overview of some of the mechanisms for asbestos release from soil. So in order for a risk to human health to be realised, asbestos fibres need to be airborne so that they can be inhaled. So if we're dealing with wet or clay soils, then the release potential from activities like wind disturbance or mechanical disturbance are much lower. However, for indoor risk, potentially wet and clay soils could stick to your shoes and get inside much more easily. So factors affecting the indoor pathway could be very much related to things like distance between the source and the property, and habits like whether you take your shoes off or how much you vacuum. So for the asbestos risk to be realised, it does need to be near surface or brought to the surface. There are mechanisms for this to happen, by things like mammals disturbing soils. Yeah, so if an asbestos containing soil was covered, a lot of those risks could be managed. Okay, so just to wrap things up, we've identified that there are many sources of contaminants that can be widespread in their presence, and they have the potential to cause harm. We've looked at a few of them in more detail. However, we know that we have a risk-based framework, and using screening tools like screening criteria that can help us to manage the risk and take appropriate action. For potentially contaminated sites, an environmental consultancy can help assess the risks and determine what action needs to be done and what the most appropriate action is. So for example, a site may have contamination, but it may not need to be remediated. We may not need to remediate the entire site, and we may only need to consider specific pollutant linkages of concern. So I haven't covered remediation here as a topic, specifically. It's a very wide-ranging topic. For us, I think it has there's interesting implications with soil quality. So following remediation, how much of a resource value could remain for a soil. So hopefully there'll be some interesting synergies there. So that's the end of the presentation. I hope that was interesting, and I will hand back to Eleanor.
Oh, that was great. Thank you very much, Simon. Just to remind everyone that we will be taking questions for both speakers at the end of the session. And our next speaker will be Stewart Powell. So Stewart Powell started working with asbestos in 1999 as a technical manager for a licensed asbestos removal contractor with responsibilities including health, safety and quality. He's currently the head of compliance for John F. Hunt Environmental and part of the SHEQ team that advises and supports a national multi-service subcontractor that employs over 1,500 personnel. Other responsibilities include developing standard operating procedures for all asbestos-related activities, audit schemes, and training courses for the safe removal and disposal of asbestos. In recent months, after a HSE asbestos licensing review, he was able to secure a 3-year extension to the current HSE licence. Stewart is also the current chairman of the SHEQ Asbestos Working Group, which helps support over 100 health and safety professionals that work with asbestos. He's been a frequent speaker for the HSE Working Well Together campaign and the UK trade and industry for all subjects relating to safe management, removal and disposal of asbestos. Stewart is the author of aspirational guidance notes and handbooks for the asbestos removal industry best practice. So over to you, Stewart.
Thank you very much, Lynn. That's a fantastic introduction to me, and welcome everybody to this webcam. Today I'm going to be speaking generally about the controls, the planning and disposal of asbestos related materials when it comes to contaminated soil. So I'm just going to try and see if I can pop up my my presentation. Bear with me for a moment. Don't know if everybody can see that at all.
Yeah, we can see that, Stuart. Thank you.
Great, okay. So everyone can see the first slide, the planning, work and disposal of asbestos containing materials in contaminated soil. So first and foremost, I'd like to start off with the Control of Asbestos Regulations 2012. Now, work with asbestos is really defined into certain sectors, but anything which is asbestos related and works with removal, repair and disturbs asbestos, which also includes ancillary, potentially has to be licensed. And also supervising work, which used to be a previous form called the supervisor license holder, although we don't see many of those at this particular time. So as I mentioned, working with asbestos is quite varied. In my years of working with asbestos, we found that I've worked in so many different sectors, whether it's social housing, retail, Ministry of Defence, parliamentary estates. The problems remain the same, although I would categorically say that each particular job has its own challenges, but the objective would be for the safe removal and disposal of asbestos. Also, our industry is heavily legislated by HSE. In fact, there is licensing conditions, and if you take in consideration, there is only 4 different types of permissioning regimes. One is explosive, one is nuclear, and the other is asbestos. So our work is very, I would say, monitored heavily by HSE. And also we have our own specific regulations called the Control of Asbestos Regulations 2012, which also has its dedicated approved code of practice, which is L143. Other guidance notes which are available called HSG 247, 210, 264, 217, and Successful Health and Safety Management, which is HSG 65, all play an integral role in managing asbestos removal practices and organisations. But if we can really start off by looking at the difference between licensed and non-licensed work, which is formally based upon risk assessment and exposure assessment. So if we take this into consideration that, so if we go back, if it takes consideration the quantification is based upon risk assessment and exposure assessment on a control which is enforced at 0.15 per centimetre cube averaged over 4 hours. Now it's a legal requirement for any type of work to remain under 0.1 unless it's licensed within a controlled environment. But asbestos removal controls are dedicated really by this control limit. So anything which is likely to exceed 0.15 per centimetre cube is likely to be licensed, and control techniques have to be adopted. Part of also those control techniques and environments mean mandatory notification to the HSE. So back to the HSE publications. Obviously, there is what we call the Health and Safety Work Act. That is the overriding regulation which we have to all conform to. But then we take into consideration the ACOP, which has been around since 2012 when the regulations were last amended. Also, I have been hearing that the regulations are likely to be observed and some changes, impending changes are likely to occur, but this won't happen probably until I'd say at least late into 2023. But all these books are available from HSE bookshops. They're available on a free download basis, or you can purchase them from HSE bookshops directly. And easy to download, just go onto the HSE website where you can quite clearly find these publications. So back to the control asbestos regulations and the control limits. As I mentioned before, any work which is likely to exceed 0.1 would automatically become licensable. So licensable asbestos removal, including contaminated in the ground, the materials which would consist of really will be spray coatings, laggings, gaskets, generally insulation materials. So we're strictly bound by the HSE to notify work 14 days before it's likely to be undertaken. And the purpose behind this is so the HSE can monitor work which represents the greatest risk and also plan for a potential site visit. Now, when we consider work which doesn't necessarily fall under licensing regime, we often refer to these as non-licensed asbestos materials. And when you consider that probably about 80% of the asbestos materials out there today are probably non-licensed, such as cement materials, Artex, floor tiles, maskets. Although we have to have very strict controls in how we're removing these materials, we don't necessarily have to notify 14 days before, although in some cases notification is mandatory, but we can do this on the same day or maybe a couple of days before the work is due to take place. And how we actually get fibres per centimetre cube? Well, it's the concentrations of asbestos in the air which is measured over a 4-hour period. So, contaminated soil removal and control techniques. So first of all, priorities must include the prevention of the exposure to asbestos and also its surrounding environments. The control measures are dictated, as I mentioned before, by the risk assessments and also the legislative controls. And one thing we also need to try and understand is an achievable program. I've been involved before in many opportunities where the program is not necessarily fit the actual task. And so an achievable program has to be identified and agreed by all parties before the work is likely to be undertaken. Also, other considerations which we may have to consider will be the type of asbestos material. So if we take into consideration 2 types of asbestos materials which are often and frequently found in asbestos in the soil, would be insulation materials, which are often referred to as loose fibres, or bonded asbestos cement materials. There is 2 different types of operational procedures and how we can actually remove these or make these areas safe. Other considerations would be based upon licensed or non-licensed work, and this again goes back to a risk assessment and also an exposure assessment. Volume of waste is also a consideration we have to take, and also the size of the working areas and the environment, because we have worked in the past where the environment is populated. It could be on a housing estate, or it could be maybe on a brownfield site, which is quite rural. The time of year also, because when you consider that that asbestos in the ground is not necessarily as hazardous as asbestos in buildings, mainly because when you consider that the ground is damp probably at least 8 to 9 months of the year, and damping of asbestos is a way of suppressing the material and reducing the risk. Also, site restrictions, access arrangements, etc., have to be considered. Budget constraints. Is the budget suitable for the task? And also, one thing you have to consider when you appoint your subcontractor, the capabilities. Are they do they have the resources to undertake large amounts of asbestos soil, and also how the work is going to be undertaken, and also check their competencies. So, as I mentioned before, there is different variations of asbestos materials which I found over the years. One control technique, which is very frequently found, would be setting up a respirator zone. These will be targeted areas where asbestos is going to be disturbance in the soil. We also must include personal decontamination areas, the use of a decontamination unit or of a preliminarily cleaned down area. Plant and equipment also must be cleaned very thoroughly and also completely decontaminated before it leaves the site. This also would include excavators and any other heavy machinery which is used to take soil away. We also have to consider adequate RP and PPE for all site personnel that enters the respirator zone. This would also include maybe a machine driver who is operating a digger or any mechanical machine. They would also have to wear the appropriate RPE, which is quite often a half-face oronasal mask with a P3 filter. Air monitoring, we also have to consider, because although the air monitoring quite often is not really that conclusive, but we have to also monitor the variations of asbestos in the air at any time. And these could be placed around the respirator zones and also inside of the respirator zone and the surrounding areas. The removal method, excavating the soil machinery, will also be used for picking up bonded materials. I'll go into a little bit more detail about the different types of operational works. And also, what's very important is the suppression methods are a key element. In other words, wetting of the asbestos-containing materials and surrounding areas is something which has to be planned and executed on a regular and daily basis. So, if I could just go back to some of the experiences which I found. So it's not necessarily just asbestos we find in the ground. We also have to take into consideration that when a building possibly is demolished and crushed, that crush can also, it's often referred to as 6F2, that can also potentially can contain some kind of contaminants. In my time, I've been involved in sites before where there's all different types of contamination, which is not necessarily asbestos, but it's just generally generally waste. Anything from wood to bits of concrete, to plastics, and even to a certain point, old crushed up toothpaste tubes which have been found in certain areas. Just general refuse of materials, which usually are very, I would say, poor quality, are 6F2. Also, so as I mentioned before, suppression methods, which I'll go into a bit later, is a real key area, because we have to ensure that the soil and the material is thoroughly wet and saturated, so therefore it will not become airborne. So when you actually take into consideration a few points, such as picking the bonded asbestos materials, this usually would be a bonded material with asbestos cement material, where the asbestos is actually bound into the matrix of cement. A common method would be just to pick these bonded materials up and place them in a sealed container or a bag and treat them as hazardous waste. In the industry, we often call this litter picking, and sometimes litter picking can go on for days and days on end, or in some cases, more of an easier process would be putting the asbestos onto a conveyor belt and picking the asbestos as it goes along. It's not a conclusive method because we rely on human nature and also the human eye to pick up these pieces. But that will be the difference between removing the material as whole as contaminated soil. So that particular example works reasonably well with bonded materials. But when we come to asbestos fibres which are loose and the material is degraded and often found to be asbestos insulation board or lagging, then it's very difficult to try and separate them or to even to pick them. So the whole of the soil would be then treated as contaminated and taken away as hazardous waste. These are two different types of practices which are very commonplace. But one thing we have to determine before is to see the level of contamination, and that's where the planning comes into. So it's what Simon was mentioning before, is the identification of the materials is absolutely fundamental to be able to allow for a reasonable and an achievable plan. So the asbestos waste. Well, asbestos is classified as a hazardous waste, so hazardous waste regulations will always apply. For small volumes of asbestos waste, we can dispose of these using a double bagging procedure, and the waste will be placed into a sealed container. This sealed container, by the way, has to be lockable when not in use. For excessive loads, then a sealed container can also be used, but this can be an open container, but it has to be lined with 1,000 gauge polythene, which would then go direct to landfill. The waste bags must also display the UN logo of hazardous waste, which has a specific serial number that identifies the type of waste, which would be amosite, croxidolite, and chrysotile. So just as the drawing displaces, the respirator zone or enclosure in very rare occasions would be erected, and then a waste route would actually be placed up. So all waste would be treated as contaminated, but also we have to take consideration that concessions have to be made. This will always be undertaken within a respirator zone. Okay, so if I can just go back to the different types and variations in the techniques we have of removing of asbestos. Suppression is also, I would say, a key fundamental point. And also, if you take into consideration, if we are removing asbestos soil during the summer months when it is rather dry, then suppression techniques have to be adopted at all times. These are usually spray-on machines, which we often find. Also, as well, there was areas where if the material was quite common found, then capping of that waste can also be considered. But when we actually undertake this task, then we would install a rubber membrane which separates the contaminated waste from the new ground. This is quite often a method which is used by developers, but unfortunately the land will still have to be treated and deemed to be as contaminated. Excuse me. Okay, that concludes my talk for this. If there's any questions at all, I'd open the floor to any interesting questions you may have. Thank you.
Great, thank you, Stewart. Thank you to all of those who have submitted a question for our speakers, and I'd just like to welcome Simon back to join Stewart in our question and answer session. And just as a reminder, submit any of your questions by 12:50 to give us a chance to get through as many as possible. Okay, so we've had a few questions come in already. And the first one I'll pose to both to Simon and Stewart. and it's a question coming in from Stephen Bailey, who asks whether asbestos degrades over time to less harmful substances or not.
If I can answer that question, so not necessarily, because when you actually take a look at the asbestos itself, it's a naturally occurring silicate mineral, so that doesn't actually rot or degrade. But the material which holds it together, which could be maybe cement or it could be a plaster, calcium silicate, that would deteriorate, which means that the fibres would then actually go into the soil. So the asbestos doesn't deteriorate; it's the matrix which holds it together.
So I have heard of some novel techniques, I think in the Netherlands, using fungus to degrade, but I certainly agree with you, Stuart. I don't know of anything that's been implemented in the field or sort of is widely recognised. And yeah, on the whole, asbestos is prevalent and will not degrade.
Great, thanks both. So Sohail Aslam has asked a question for Simon and asks if you can elaborate on how imported soils impact, and I presume he means with regards to the conceptual site model.
Yeah, so imported soils, just in terms of the sort of risk assessment process, they would be flagged as a potential source, but it really does depend on what we know about those soils. So a lot of the sites I deal with are quite historical sites. So any made ground that was brought in, there's not really much known about it. It's probably whatever dodgy materials kicking around the area at the time that just got reused. A more modern development, there'll be much stricter controls on imported soils, and you would hope to have some kind of reassurance testing done either before the materials went on or validation on the site, so that any materials brought on more recently would be suitable for use and they shouldn't be a contaminative source.
Thank you, Simon. So Glyn Mitchell has asked a question for Stuart, and he asks, if plasterboard is crushed and added to the soil as a form of gypsum, what contamination issues should we be aware of?
Well, gypsum doesn't necessarily come under hazardous waste regulations. It's not necessarily hazardous material, but when it becomes crushed, it can be used as a binding material. So I don't necessarily feel that that crushed gypsum board is used as any form of piling at all. So I wouldn't necessarily recommend to use that as such.
Great, thanks for answering that, Stuart. And another one for you, Stuart. Dean Carter has asked, can I ask how toothpaste was discovered during Stuart's remediation project, and was it a fresh find?
No, what was, you see, there was a job which we was working on, and there was some imported 6F2 which was put onto the site, which was really poor quality, and it had all different types of rubbish in there, which all different types of plastics. And one thing which was noted was there was all different crushed different types of refuse, and one was just happened to be a tube of toothpaste.
Thanks. Another question that's come in. Which analytical techniques do you use to determine an asbestos content in soil less than 1%?
Okay, Simon, if you want to answer that one.
Yes, yeah, that's fine. So the asbestos laboratory assessment process goes through various tiers of assessment. But if you're looking for free fibres, the process is a phase contrast microscopy. So this would determine asbestos fibres typically down to about 0.001% within soils. That doesn't quantify the soils, but that would tell you what type of asbestos is in there. if you wanted to quantify the soils, the method depends on the form of asbestos and the concentrations. So you may have gross contamination where it's simply picking it up and picking it out and weighing it, so sort of gravimetric quantification, or it may be under a microscope where the analyst is counting the asbestos fibres on the graticules and then inferring an average weight for each asbestos fibre counted. So that's generally how it's done, but the methods of quantification wouldn't tell you what type of asbestos it was. Okay.
Thank you for that, Simon. So that's all of the questions that have come in so far to our slides. So if anyone else has any questions, please do. Yep, we've got one that's just come in. So asbestos loose fibre, not bound in a matrix, determined to be less than 0.1% by quantification and qualification. Does this mean that soil is not classed as special or hazardous waste?
Shall I cover that one, Stuart?
Yeah, thank you.
So the hazardous waste threshold for asbestos is 0.1%. So absolutely, it wouldn't be considered a hazardous waste. It doesn't. I mean, there's often confusion between something being a hazardous waste or not, and being, still being a problem. So just because something isn't hazardous waste doesn't necessarily mean it's suitable. You could, 0.1% is 10,000 milligrams per kilo. It's still, or 1,000 milligrams per kilo. It's still a reasonable amount of asbestos, not classifying the material as hazardous, so subject to those landfill taxes, but it certainly wouldn't be suitable in many scenarios to be reused. Okay.
Thanks, Simon, for that. So there's no further questions coming in. So I'm gonna ask a question. With an increased awareness of soil health and the importance the soil resource has in delivering a range of ecosystem services such as carbon storage and flood risk mitigation, there's a drive to reuse soils as much as possible on construction sites. And how can this be done with soils that have been identified as containing asbestos? So would you remediate the soils?
So
it would really be the actual classification that the type of asbestos which has been found, whether it's bonded or whether it's insulation materials, which would be determined during the risk assessment and exposure assessment at that particular time. So it's difficult to answer a question about that until you have fundamental reassurance as to what the material is before it becomes remediated.
Yeah, just like to add, if that's all right, that just because there is asbestos within soil, it doesn't automatically condemn the soil. The suitability for reuse depends on the scenario and the condition of the asbestos, type of asbestos, as Stuart said, and yeah, there can be other methods in place rather than just removing the soil to manage the risk from asbestos, such as where those soils are reused on site. Things that are reused beneath a building area, beneath a car park area, would be more sustainable than taking them off site if that was an option.
Okay. And there's a question that's just coming from Stephen along the same lines, asking whether the current British standard for topsoil contains a limit for asbestos.
With the limit of quantification, as Simon said earlier, that would determine whether you have asbestos within the soil or not. So it's the investigation work which would determine that level if it exceeds the threshold.
It's quite a difficult thing to determine the de minimis value. So I don't think there is a criteria set for topsoils. As such, you would expect no asbestos. But so we talked about earlier, with background concentrations, if you analyze low enough, you probably will find asbestos fibers. So I would be working, as Stewart said, to the commonly accepted method detection limits, where you're going to pick up any significant contamination. But that's not necessarily risk-based. It is, based on the available technologies. Okay.
Thank you both. So that's all of the questions answered. Thank you. So if no one else has any other questions, I can't see any coming in. On behalf of the British Society of Soil Science, I would just like to express our thanks to Simon and Stewart for coming along to present today. And thank you also to ACAD and Arcadis for supporting this webinar. And thank you for those for attending. You'll find a quick feedback survey when you leave the webinar, which we hope you'll take time to complete. The recording for this video will be available after the event on our YouTube channel. And as mentioned at the start, we have one more webinar planned for this year, which will take place on World Soils Day on the topic of HS2. This webinar is now available for registration via our website, and we will send the link out to in our follow-up email. I hope to see you at future events, and in the meantime, thank you again and goodbye.